Internal energy as a state function. The internal energy as a state function. So first of all, we will try to understand the internal energy. Actually, this internal energy is the sum of translational energy, rotational energy, vibrational energy, electronic energy, etc. So it means it includes all types of energy within a system. This internal energy, as I already mentioned, is the function of temperature and volume. That is, this internal energy change taking place at constant volume. If it is a chemical reaction, it is the heat exchange that takes place during the chemical reaction at constant volume. That is internal energy change. And I also introduced about the heat content, that is enthalpy. That enthalpy change is the heat change accompanied by the chemical reaction, in case of chemical reaction, at constant pressure. So what about internal energy? Heat exchange taking place at constant volume, whereas this one is heat change taking place at constant pressure. So that makes the difference. Are you able to follow? Right. Now, in thermodynamics, this internal energy change takes place when heat is passed into the system or out of the system. When I say heat is passed into the system, it means heat absorbed by the system. Got this point? And heat is given out by the system. So heat is absorbed by the system is called endothermic process. Endo means inside. So endothermic process means it is the change in the system taking place by absorption of heat. Exothermic means heat is evolved, heat is given out. So we must always talk about the exchange of any energy based on the system only. For example, when heat is absorbed by the system, it is the gain to the system. So it is positive. When heat is given out, it is lost to the system. So it is negative. Do you understand this? So exothermic is negative, endothermic system is positive. And you may be interested to know the process. What do you mean by process? It is the change taking place in the system. So whenever any change is taking place in a system, either it can absorb the energy or release the energy. Are you able to follow? So based on that, we classify the process into endothermic process and exothermic process. So endothermic means heat is absorbed. Exothermic means heat is evolved. So endothermic process is represented positively, is it not? Exothermic means it is a loss. So negative. Similarly, work can be done on the system. For example, when you pressurize the piston, when you force the piston externally, now you are applying the work on the system. Then in turn, what you can expect, the system will reciprocate, is it not? So the work is done by the system. So similar to the heat, work is also associated with the system. Either work is done on the system or by the system. Work is done on the system means positive, by the system means negative. Sometimes the system would not allow any change of heat between the system and surrounding. Like in the case of vacuum flask, you have got a jacketed layer where you have got the vacuum, and that vacuum jacket will not permit any exchange of heat between the system, that is the tea inside the hot tea inside the flask and the surrounding. So they are two different, that is the system is totally isolated from the surrounding. Is it not? So they maintain two different temperature. For example, your tea is very hot, whereas the surrounding is cool. So there must be transfer of heat from hot to cold condition. Is it not? But because of this insulated wall, that wall is called adiabatic wall. Please make a note. So what is the adiabatic wall? That does not allow any heat transfer between the system and surrounding. So such a system is called adiabatic system, and whenever any change is taking place in that adiabatic system, it's called adiabatic process. So adiabatic process is a process in which there is no transfer of heat between the system and surroundings. And such a type of wall separating the system totally from the surrounding is called adiabatic wall. So one thing is clear. An adiabatic system does not permit the transfer of heat through its boundary, that is wall. So probably that is initial stage. Before undertaking any change, the internal energy of that state is U1. After the change is taking place, it is U2. So what is the change in internal energy? Delta U is equal to U2 minus U1. Otherwise you can keep it as AB also. So UB minus UA. Otherwise UF minus UI. So final minus initial. Got this point? Therefore delta U is equal to U2 minus U1, that is equal to the work done in adiabatic system. So this is called adiabatic work. When adiabatic work is positive, the work is done on the system. And the internal energy of the system decreases. If the work is done by the system, then adiabatic work will be negative. Why? Because the internal energy of the system decreases. So this point is very clear. So during adiabatic process, what happened to this internal energy? There is a drop in internal energy. Got this point? Now let us consider a system that allows energy transfer. That is, energy is transferred as heat. So this is not adiabatic, this is isothermal, let us say. Iso means same. Temperature, thermal, temperature, heat. Isothermal at constant temperature. Now let me consider a piston and barrel assembly. let me consider two systems. One is adiabatic, another is isothermal. In the case of adiabatic, what I suggested, when work is done on the system in an adiabatic wall, there is no escape of heat. So during compression, heat is enormously increasing. Is it not? Let us consider a cycle pump. Okay, and that is, let us assume it is completely isolated, that is insulated. Okay, now let me compress. What happens? There is an increase in temperature. Why? Because there is no transfer of heat. When it expanded, the temperature is decreasing. So during adiabatic expansion, what occurs? Temperature drops. Okay, right. And what about this isothermal system? Iso means heat is, temperature is constant. So in that case, we put the normal wall. When we compress slowly, what happens? The change in heat is transferred to the external surrounding. Are you able to follow? Because it allows the heat. Okay, and when you slowly expand it, nothing takes place. So it means the temperature is constant because it transfers the temperature. Are you able to follow? So in that case, we have now the system that allows the heat transfer through its boundary. The heat transfer is represented by Q. That is the amount of heat transfer through the wall, is it not? So this delta U, the change in internal energy, is equal to the Q. Delta U is equal to Q, small q. This quantity of heat transferred, this depends on the path. So it is a path function. It is not thermodynamic property. So it should be represented by small letter. Do you understand this? So all thermodynamic properties should be represented by capital letters, and all non-thermodynamic properties should be represented as small letters. Okay. So Q, that is heat transfer, is non-thermodynamic property. Small q. Okay. And in this case, this is equal to the change in internal energy. What is internal energy? It is a thermodynamic property. So how to represent that? Delta capital U. So delta capital U is equal to Q. Got it? And there is no work done at constant volume. So by conventions of Vayu-Pok in chemical thermodynamics, the Q is positive when heat is transferred from surrounding to system. Please make a note of it. When heat is transferred from surrounding to the system. So in this case, Q is positive. Okay. And what about the internal energy? There is an increase. Okay. And what do you call this heat transfer into the system? Endothermic. Is it not? So during isothermal endothermic process, I hope now you should be aware of this language. Isothermal means at constant temperature. Isothermal endothermic means endothermic process means heat is absorbed. Okay, at constant temperature the heat is absorbed in an isothermal. Okay, isothermal at constant temperature. Okay, right. So the internal energy of the system increases. Next one. Now, second case, the Q is negative. The Q is negative when heat is transferred from system to surrounding. What do you mean? What do you understand from this? System to surrounding mean it should be exothermic. Heat is given out, right? So when heat is transferred from system to surrounding, there is a decrease in internal energy of the system. There is a decrease in the internal energy of the system. Okay. Next one. Now let us talk about the general case. In the general case, delta U is equal to Q plus W. Take down. Delta U is equal to capital U is equal to Q, small q, plus W. W is also a state function. Sorry, path function. Small w. W is work. So work is non-thermodynamic property. Why? It depends on path. It's a path function. It's not a state function. What is the condition for a thermodynamic property? It should be a state function. It means it should depend on initial state and final state of the system and does not depend on the path followed by the system. Now let me consider, I asked you, that is you are supposed to touch your nose with your finger. You can put it directly or round the head, round the neck you can do. So the effort is definitely different, is it not? Because of the path. So work is a path function. Got this point? In what route, in what way, in what direction it is applied. So that definitely changes. Okay. So it is non-thermodynamic. Similarly, Q, quantity of heat transferred. Okay. So Q and W are non-thermodynamic properties or non-thermodynamic functions or parameters, whereas delta U is a thermodynamic. It can be called variable. Properties means variables. Properties means that is always variable, you know. Property, today you are rich, tomorrow you may be poor. It is variable, is it not? So variables, it can be varied. Nothing is constant in this world. Your youth, your age, everything changes. Your time. So the variables can be divided into intensive variable and extensive variable. Please note this point also. What do you mean by variable in that case? The one which varies. Sir, is there anything which is constant? Yes, but we arbitrarily fix this as constant. Is it not? So, the opposite term is constant. For example, when we consider pressure, volume, temperature, if you want to study pressure and volume, you have to maintain the temperature constant. If you want to study pressure and temperature, you have to maintain the volume as constant. Likewise. Okay. Right. So these variables can be classified into extensive variable and intensive variable. Please make a note. Extensive and intensive. This extensive variable, it depends on quantity of the system. Whereas intensive property depends on quality of the system, that is nature of the system. I can take 1 liter of water. I can take 1 liter of honey. Okay. Now the volume is what? Constant. In both the cases it's constant, irrespective of the quality. We depend only on the quantity. So the volume is the quantitative property. That is called extensive property. But this 1 liter honey is more viscous than 1 liter water, whether it is 1 liter or 2 liter or 1000 liter. Are you able to follow me now? So because this viscosity is the nature of the system. So viscosity is the intensive property because it depends on the nature of the system. I hope now you should be able to understand. Even this refracting index, that is also dependent on the nature of the system. Now, as I already mentioned, this delta U plus Q plus W is the mathematical statement of first law of thermodynamics. Please make it ready. So, the mathematical representation of first law of thermodynamics is delta U is equal to Q plus W. According to this, the energy of an isolated system is constant. So energy can neither be created nor be destroyed according to first law of thermodynamics. One form of energy can be converted into another form. But you cannot claim that you have generated energy out of nothing. After all, you are converting one form into another form. Do you understand? And that is why it said energy is neither created nor destroyed. Energy is interconvertible. It means one form of energy is converted into another form. So this is first law of thermodynamics. So now let me summarize these three cases. Take down. Summary. Delta U, capital U, is equal to WAD. W at the subscript you can put AD. This is called adiabatic work. That is, the wall is adiabatic. Second case, delta U is equal to minus Q. The wall is thermally conducting. Third one, delta U is equal to Q minus W. It is a closed system. And we also defined the system into three classes: open system, closed system, and isolated system. In the case of isolated system, what is the nature of the wall? It is adiabatic. That is, it doesn't allow the energy transfer between the system and surrounding. So these are all the very important aspects about the first law of thermodynamics. Okay. So let us continue in the next class.